Hello all, today in this video I'm going to provide details regarding an kidney disease dataset, kidney disease classification using hybrid CNN and SVM. For that initially we are just declaring the CNN model and the output of the CNN. We are grabbing it as the features, and that features we are using in the CNN classification to perform the classifier. So this is the outline of this hybrid CNN and SVM which we have done. Then this code which already kidney disease classification already we have done for three classifiers such as SVM, ANN and CNN. For the same code only we are doing this. So initially the data set declaration and other things you can see in that video also. So here I am just showing a preview that initially we are just reading our data set and declaring its values, and some values are in uh, floating, that is string, so that we are going to neglect. But the classification variable, that is the final prediction variable, is also in string, that also we have to convert into number. For that we are just using some steps to convert it into numericals or integers. Then we are just declaring the x variable and y variable. By using this x variable and y variable, we are just using the train test split function to declare the four variables like x train, x test and white train and white test. But we have to resize this variables. Why? Because it is having only two dimension, but in CNN it will accept only three dimensions, so we have to reshape our variable. So we are going to reshape our variable. Here you can see we are reshaping, and this reshaped variable only we are using in our code. So these are the previous CNN and ANN code. Now this is the CNN with hybrid CNN SVM code. Initially we are declaring layers. In the CNN which we are using, we are having nearly two C convolution 1D layers followed by a batch normalization and dropout layer. The batch normalization and dropout layer usage will just reduce the overfitting and underfitting issues which will be occurring in a machine learning model. And then followed by the dropout, we are using max pooling layer with the pool size of 2, and then flatten layer. The initial dense layer we are calling 10 hidden layers, and in the final dense layer it is 1, since our classification is a binary classification with two prediction variables. And finally we are just compiling by using the Adam optimizer and binary cross entropy, and the metrics we are using is the accuracy. Then we are just training the model by using the X train and Y train function, and also the approaches we are training for 50 approaches. In this proposed output, we are just making it to features train and features underscore test. This features train and test we are just using in the SVM classifier. You can see here we are using features train for training, and testing we are using features test. Based on that we are declaring the accuracy of the hybrid CNN SVM model. Then we are declaring the confusion matrix parameters and also the other parameters, the performance metrics parameters. Initially, the classification with the CNN will be done. After that, this output will be given to the SVM classifier, and that SVM classifier confusion matrix is given over here. And based on that, it will be displayed some different confusion matrix parameters like precision, recall, F1 score, support, accuracy, macro average and weighted average. In this code, already in the CNN and ANN itself we got nearly 100% accuracy. So here also we are getting the same 100% accuracy, but with some variations. With that variations will be mostly some decrement in this loss. Here our initial loss was 0396. So we can check with the previous functions loss. Here you can see, but it's not much difference. So this is the code for the hybrid CNN and SVM with kidney disease dataset. So in the next video we can find some other way, work with different languages like Python, Vika and MATLAB. Thank you.